Copper is one of the most important metals on Earth. Every day, more than 100,000 tons of copper are produced around the world. It powers our cities, carries electricity through vast networks of cables, transfers heat inside industrial systems, and helps operate countless machines we rely on every day. More than 26 million tons of copper are used globally each year. But where does all this copper come from? From deep inside the Earth to the products that power the modern world. Every copper mine begins with a search. Before any excavation can take place, geologists spend years studying rock formations, analyzing samples, and using advanced surveying technologies to locate underground copper deposits. Only areas containing economically viable
Once a promising deposit is confirmed, large-scale mining operations can begin.
In northern Chile, deep within the harsh Atacama Desert, lies Chuquicamata, one of the largest open-pit copper mines on Earth. This enormous excavation stretches across the desert landscape and produces hundreds of thousands of tons of copper every year.
However, reaching the valuable ore is not easy. Massive layers of waste rock must first be removed
before miners can access the copper-bearing material hidden below. Some deposits extend more than 100 meters beneath the surface,
requiring powerful machinery and carefully planned blasting operations.
The first major task is drilling. Giant drilling machines create around 130 blast holes across the mining area. Each hole can reach depths of 16 meters, roughly the height of a 5-story building. After drilling is complete, the holes are filled with a mixture of ammonium nitrate, fuel, and high-energy explosives. The remaining space is covered with waste material to control the blast. When everything is ready, operators initiate the explosion sequence from a safe distance. The blasts occur in carefully timed intervals of just a few milliseconds. This precise timing allows the explosive energy to break apart huge volumes of rock, while minimizing dust and unnecessary ground movement. Within seconds, millions of tons of rock are fractured and prepared for extraction. Once safety inspections are complete, enormous excavators move into position. Their giant buckets scoop up the broken rock and load it into some of the largest mining trucks in the world. Each bucket can lift between 55 and 88 tons of material at a time. The trucks themselves stand nearly 7 meters tall and can carry as much as 400 tons in a single trip. To put that into perspective, one truck can transport roughly the same weight as 300 passenger cars.
Despite all this effort, the ore often contains less than 0.5% copper.
Not all copper ore is the same. When the ore contains copper oxides, it is sent to special leaching areas.
There, the crushed rock is stacked into large piles and continuously sprayed with a diluted sulfuric acid solution. Over several weeks, the acid slowly moves through the rock, dissolving the copper and carrying it away in solution. The copper-rich liquid is collected and transported to a processing plant. Next, chemical reagents are added to separate and concentrate the copper. The solution then enters large electrowinning tanks,
containing thin copper starter sheets called cathodes. After approximately 10 days,
thick copper sheets weighing around 125 kilograms each are produced. Their purity reaches an impressive 99.99%. Sulfide ores require a different approach. The ore first enters massive grinding mills, where heavy steel balls crush the rock into fine particles. Screens separate the material by size. Larger pieces return for additional grinding, while finer particles continue through the process.
Special chemicals are then added to make copper particles repel water.
As air bubbles rise through the liquid, copper particles attach to them and float to the surface.
This mineral-rich foam is collected and filtered, producing a copper concentrate containing roughly 25 to 30% copper.
The concentrate is transported to a smelting facility. There, it is mixed with silica sand, known as flux,
which helps remove unwanted impurities. Inside enormous furnaces operating at extreme temperatures, the material melts into a liquid.
Impurities combine with the flux and form slag, which floats on top.
The heavier copper-rich material settles beneath it. At this stage, the copper reaches approximately 60% purity.
Further smelting and refining increase the purity to around 98%.
The molten copper is transferred into large molds, where it solidifies into thick rectangular plates called anodes.
Water sprays cool the molds and accelerate solidification. Once hardened, hydraulic systems remove the anodes automatically.
Cleaning systems wash away remaining residues before the plates are prepared for shipment. Although already very pure, the copper still contains trace impurities that must be removed.
The anodes are transported to a refinery. Here, they are suspended inside large tanks, filled with an electrolyte solution. Thin metal sheets serve as cathodes and are placed between the anodes. When an electric current flows through the tank, copper atoms leave the anodes and deposit onto the cathodes.
Meanwhile, impurities separate from the copper and settle at the bottom.
The result is copper with an extraordinary purity of 99.99%. This level of purity is essential.
The refined copper is melted once again inside a vertical furnace. The molten metal flows into a casting system, where it forms a continuous rectangular bar.
As the copper moves through the machine, water cooling solidifies it. A series of powerful rollers then gradually reduce its size,
transforming the thick bar into a copper rod only a few millimeters in diameter. The rod continues through the production line and is automatically wound into large coils. These coils are compressed, packaged, and prepared for transportation.
Soon, the copper will become electrical wire used in homes, factories, power grids,
and countless technologies around the world. From geological exploration and controlled explosions
to advanced refining and wire production, copper undergoes an incredible journey before reaching our everyday lives.
It is a metal that powers modern civilization and remains one of the most important resources on Earth.
If you enjoyed this journey into the world of copper production,